For now, I'm going to take it slow and just focus on how to drill down to find the resistance totals for these combination circuits. So we'll find the rest of the values as we move on a little bit deeper into this, but we're just going to kind of phase in on making sure we know how to find the resistance total values for combination circuits and how to break it down and kind of dissect it to find that. Once we have that, it'll enable us to find and solve for a lot more of the information. But let's just take an overview look at this problem right here. So you can see there's 4 resistors, and 2 of them are hooked up in parallel above, and 2 of them are hooked up in parallel below. And those 2 parallel sets are in series with each other. So you'll kind of get more comfortable seeing exactly what order to separate them in and the easiest way to do it. But I can kind of see here that if I combine these 2 into one value and get the ohms for this unit here, and then I do the same thing down below, I can turn this into a simple series circuit, which is much easier to solve. So let's go ahead and look at how we would do that. So if we had 2 parallel resistors here, we already have the formula to find that, right? So the resistance total for that, just that area, would look something like this. So this right here is going to give us our value for R1 and R2 only if we were to combine them. So let's go ahead and see what we get there. So 1 divided by parentheses 1 divided by 100 plus 1 divided by 250. So that gives us 71.429 if you round up ohms for that one. 71.429. So let's do the same thing for down below. So the RT for resistor 3 and 4, it's going to be 1 divided by 1 over 350 plus 1 over 200. So if you plug those in, that gives us 127.273 if we round up. 127.273. So while these 2 values independently don't really tell me anything, they do show me what this circuit would look like if these 2 values were hooked up in series. So now I just have 2 big resistors hooked up in series, and from what we know on our series circuits, I could just add up those resistor values. So if I take 127.273 and I add that to 71.429, that gives me an overall value of combining the 2 of those of 198.702. So this new value here is the imaginary resistor that would have the same value if all of this was just one big resistor, which is our resistance total for the whole circuit. So our resistance total here is 198.702 ohms. So they gave us the voltage, and if we were taking this further, we'd have the voltage total of 24. And you can see just with those 2 values, we can start to take this problem even further. So let's do a little bit more practice, just breaking down the resistance values, and then we'll start getting into looking at how to fill in these charts further, breaking down the voltage, current, and resistance of each individual resistor.